I think we'll get started now because we've got a hard stop at 11:15. So good morning to everyone and welcome to this first IMIA leg joint session for the working group Cladding for Buildings. For those of you who don't know me, my name is Cedric Wong and I am the chairman of the London Engineering Group. And this session forms the opening of the second day of the LEG conference, which is going on at the moment. Now, we've been talking with IMIA. The London Engineering Group have been talking with IMIA over the last 3 or 4 years about closer interaction. And I think it makes a lot of sense because we look at common topics where we face the same issues and we have a sparse resource as well. So combining forces where we can really makes sense. And we've been discussing in the conference as well how we can improve that collaboration going forwards. So I'm really happy that we're having this first session. I'm going to now hand over to the sponsor of this working group paper, Guido Benz, who's going to introduce the speakers and the topic. So over to you, Guido.
Thank you, Cedric, for the introduction here. As mentioned, I'm Guido Benz. I'm heading up the Engineering Construction Department of Swiss Re Corporate Solutions, and I'm the sponsor on behalf of the IMIA Executive Committee for this work group paper. I think just in terms of a little housekeeping at the beginning, throughout the presentations, if you do have any questions, please register them, enter them by the chat box in the control panel of the GoToWebinar software. You have this red-orange arrow on the right of your screen. Typically, if you click that, it will open up the control panel. You have a drop-down menu there where you can enter your questions. We will pick them up at the end of the session and respond to them during the Q&A session for the presentation. So, I think recent major incidents associated with loss of life, complex liabilities, and large-scale damage put cladding in buildings in the spotlight. And this was really the trigger to agree and decide to have a work group paper launched on that topic on behalf of IMIA. I think similar considerations led to the same conclusion on behalf of the LEG group. And as Cedric mentioned, this was very much a joint effort and resulted in a very comprehensive work group paper, which covers topics like cladding types, technical aspects in general, will reflect on risk management aspects and insurance coverages, as well as bringing about underwriting considerations, risk engineering topics, and of course also looking at some claims experiences to really address the topic from all the various angles. The presentation today will be conducted by Andy Kane. He's the chairman of the work group paper. Andy is the construction portfolio manager of QBE for the European operations. He's also a member of the IMIA EC since about 2 years. And in terms of maybe something that is less well known, he was recently doing a 3-man bicycle ride from Johnnegrove to Land's End. Then the presentation will also be supported by Mamoun Alia. He's a civil engineer. He's the managing director and principal engineer of Sea Risk that you've probably come across. Mamoun is investigating engineering accidents in complex electrical and mechanical systems, in addition to carrying out risk assessments of construction, engineering types of properties. He's a frequent speaker at insurance conferences and has chaired a number of IMIA working group papers on power systems, including combined cycle power plants and electrical failures. And something that people may know less about Mamoun, he's an avid kayaker. He loves kayaking, though he spends most of the sea expeditions trying to get back into the boat after flipping over by waves. Nonetheless, he just keeps going and going and going there. Then, in addition to the presentation, we will have some contribution from Richard Gordon. He's the underwriting manager for the engineering department for Zurich in the Dubai International Financial Center. Richard Gordon is basically a civil engineer by training. He started his engineering insurance career in 2011, initially with Infrasure in Switzerland. He then joined Zurich Insurance and Company in 2015 in London before moving to Dubai in 2017. He did work for 18 years as a chartered civil engineer prior to his insurance career, where he was mostly involved in civil infrastructure projects in the UK and overseas on some schemes in India and Kazakhstan. So for Richard, having lived in Dubai for 3.5 years, he can confirm that he's yet to play golf more than once a year. And one of the key factors is that he has a very high loss ratio in terms of golf balls, of course. Then finally, the presentation will also be including contribution from Tim Chapman. He's the head of construction IMIA for SCORE, based in London. He's the chairman of the ISIC group, civil engineer by training, worked as a loss adjuster in his previous life, and he's also an avid sailor, currently spending his spare time with renovating a very old sailing boat. With that, I would like to pass on to Andy Kent to take over the presentation and manage the slides throughout that. Andy, over to you. Thank you.
Thank you, Guido. Hopefully everybody can see my screen and the slides. Let me know if you can't. As on the GoToWebinar, it isn't the easiest software to use. So thank you everyone for attending this morning's first joint working group paper presentation. I think it's a great opportunity, as Cedric already mentioned, for LEG and IMIA to work more closely together. I'd like to start by thanking Guido for sponsoring this paper. It's a very important topic, and I think hopefully this should be a good information paper for underwriters in the business. Let me just see if I can move this. So today we're going to talk through some claims and case studies, discuss different types of cladding, look at specific risk engineering issues around cladding, the underwriting considerations that we need to consider when we're looking at these risks, a brief discussion on insurance coverage, and summary at the end. You've already had the introduction of the presenters, so I'd like to thank everybody presenting today, and also Bianca Jung from R&V, who's joining us to help answer any questions following a lot of work that Bianca did on collating the claims log of larger losses. So I'd like to thank all of the team who contributed from both IMIA and LEG, and we should be in a position to publish the document by the end of October. We've still got a couple of final formatting to clear, peer review, and checking for typos, etc. So just to introduce the issue with cladding. We know that cladding has been identified as a significant issue in a number of high-profile fires globally, some of those extremely recent. The most recent large tragedy here in the UK was the Grenfell Tower fire, which highlighted serious issues with building regulations, the building control process, and also the culture within the construction industry around the procurement of buildings. I think all of this makes this a highly relevant topic for construction underwriters, and I'd obviously commend you to read the paper when published. The presentation develops on some of the topics presented by Simon Ince of UL at last year's conference around cladding testing, and it's unfortunate. We were hoping that the Grenfell inquiry would have concluded before we could publish the cladding paper, but because of delays, initially because of Brexit and then because of the coronavirus, we've not been able to align that, unfortunately. So the paper itself considers the cladding types and technical aspects, focusing strongly on fire rating and types of insulation. And Mahmoon will talk us through that today. It looks at general risk management in terms of the influence and understanding of applicable building regulations and the resilience of buildings that are impacted by their design. Insurance coverage. I mean, it's interesting that cladding issues have impacted on many lines of business, not just property, which is obviously very high profile, but also construction to a lesser extent, IDI, and also professional indemnity. So we'll look at some of those issues. We look at the underwriting considerations already mentioned, risk engineering, and I think what's really interesting, some of the claims statistics. And we'll move on with claims as our starting point. So the group identified 75 cladding-related fire claims since 1973. So the earliest claim that's looked at is the Summerland disaster in the UK. The fire at a holiday complex on the Isle of Man killed 50 people and led to changes in the building regulations in the UK. So 44 years later, on June the 14th, 2017, the Grenfell Tower fire led to the deaths of 72 people, and the public inquiry is currently taking place. So far, the issues identified include material selection, unclear roles and responsibility for checking design and specification compliance with building regulations, design errors, poor installation of safety critical components, and lack of quality checks on the site. And that disaster has also led to a review of building regulations 44 years later. We're looking at 4 particular case studies in the paper. Grenfell is one of them. The others, 2 construction losses, the Haramain train station in Jeddah, Torre Windsor, which is a slightly older loss in Madrid in Spain, and also the La Crosse Tower in Melbourne. Just to show, that this is remains a very relevant topic. We're aware of 2 recent claims that we've added to the log. A hospital under construction in Kuwait that caught fire in September. We know the cladding is a factor of that fire at the Al Sabah Health Zone in Kuwait City. Reports say it was also contributed to by poor material storage on the site. And then last week, a rather spectacular fire in South Korea in an operational apartment building. And we are going to see if we can get this video to work so that you can have a look at it. Hopefully everybody can see that. Sorry, let's take it back to the start. So this is a fire that spread very rapidly across multiple floors of this apartment building and hotel in Ulsan in South Korea. Fortunately, no casualties, no fatalities as far as we're aware. You can see that characteristic of a cladding fire of burning debris showering down and floating around the area. So this was a 33-story apartment building. And it looks like the cladding contributed to extremely rapid fire spread. It's believed to be aluminium cladding, similar to that in the Grenfell Tower. Let's go back to the presentation. Let's just close that. Go back to the presentation. So one of the things we looked at was cladding fires over time. what you can see is that prior to 2007, there were not cladding fires every year, and they were relatively infrequent and rare. However, that may be because of lack of reporting or records not being available for more than the largest and highest profile losses. From 2007 onwards, there are recorded fires every year, and it looks to be an increasing trend when you look at the numbers per year. In terms of territory, you can see that it is an issue that has touched many countries over the world, but there is a clear cluster of claims in the United Arab Emirates and also the UK. When we look at occupancy, we could see that there are a number of occupancies that have been impacted by fires, but by far the highest are residential and then also industrial. So we would always potentially consider residential as a lower risk fire occupancy for construction, but you can certainly see that it has a high incidence of cladding fires. In terms of type, this is harder to determine accurately because we're taking everything from publicly recorded information, but you can see that aluminium cladding panels and what are described as general composite panels feature significantly in the large fire database. And there you can see that the aluminium composite panel is approximately a third of the claims as the other metal composite panels are. Similar with exterior insulation finishing system coming up on third. And as I mentioned, it was not possible to determine the insulation material in most of the cases and to find out the detailed classification of the panels or testing regime under which they were assessed. So with that, I'm going to hand over to Richard Gordon, who's going to talk through one of the case studies that is in the paper, the Haramain train station in Jeddah. So Richard, will you be able to turn your camera on and unmute yourself?
Yes, indeed. Thank you, Andy. Thank you very much. And good morning, good afternoon, good evening all. I'm just going to discuss the Haramain station risk and the fire incident from September 2019. The Haramain station railway is part of the 7.3 billion scheme that was partially inaugurated in 2019, and it connects the Muslim holy sites of Mecca and Medina with the Red Sea city of Jeddah, with the high-speed trains travelling up to 300 kilometers an hour. The project aligns with Crown Prince Mohammed bin Salman's vision for 2030, and there's a lot of ongoing change in Saudi Arabia, making it a very exciting country for the future. So the fire happened at a very late stage in the project. We haven't got, you know, some of this may be approximate details, but the project was virtually in handover mode and ready to be put into an operational BI program. And what happened was there was ongoing elements of work going on the roof, and that, whatever contributed, started the fire. What is quite scary and quite frightening is the speed of how fast this fire spread throughout the structure. And we've been talking about vertical cladding, but this is actually a horizontal cladding, and I'll show you in the next picture how the landscape of the sort of roofing configuration looks like. The fire started, and I think, sorry Andy, could you just go back one back? Sorry, yeah, you can just see in the picture there's some helicopters, and when these structures start to burn, you've got to think about how the firefighters will respond and access to these key areas as well, and if it's actually possible to actually distinguish the fire. And also in the next page as well, which if you could go to now, please, Andy. You see on the left-hand side picture, there's a shot on the roof as well. This roof isn't actually finished. You can see there's bits of snagging works ongoing, but it's like a golden mosaic tile finish, and with the roof lights looking like diamonds. And then if you look to the right-hand side, you've got the picture of the sort of station concourse where passengers would travel to the train, and you've got the light coming down. You know, quite an attractive architectural feature. So, Andy, if you go to the next slide, please. Okay, so then just to talk about the impact of the size of this fire loss. If you take the picture on the left-hand side taken from Google Earth, we've approximated the blackened out area there to be 212 meters by 183 meters in dimension, so which is about 40,000 square meters approximately in roof area that looks like burnt. We don't know about the surrounding areas, etc. Now on the right hand side, I think this is Wembley Stadium. To give you an idea, that pitch is 105 meters by 68 meters, which is 7,500 meters. So we're talking something in the scale of this station roof that was destroyed. It's 5 times the area of Haramain, of the Wembley Football Stadium pitch footprint. So when we go back to the picture, the roofing material was combustible. It's obviously expanded polystyrene foam and polyurethane components. There's no actual breaks in the actual structure or the uniformity of the panels. So no break, no fire break, and hence with strong winds and a source of fire ignited and completely burnt through. Now, the station will have to be rebuilt, and it's part of many similar structures on the project, and also within the time frame of this project, which started in 2011. Saudi Arabia is also changing its cladding and specifications, civil defence, the details and building specifications. What I'd like to do now is show you a couple of videos of the project. These are taken from YouTube, but it shows one is the fire ongoing, which is, I think Andy will drag through to the key elements. There isn't, I don't think we'll be able to have noise, but you can see the black, acrid, toxic smoke, high heat release and intense, fast spreading fire. You know, it's very corrosive and toxic. It's difficult to put out, and it burns just like petrol and gasoline. And I think it was a burnout philosophy really once the fire brigade arrived on site. Fortunately, I mean, I think the best saviours, loss of life was not happened, but people were obviously taken to hospital, and there were people rescued off the roof. It's just quite frightening how this happened from a simple, possible, innocuous hot working process going on the roof structure at the final stages. And it burnt all day and all night. So the next video, I think Andy is when the fire brigade and people actually gain access to the destroyed concourse location. And if you could link. Now, what also should be said as well, this, let's say the project was in its final stages. You can see the ticket machines. There's also, I'm aware of, claims to not only the construction project, but also utilities and providers for the permanent works under our operational program as well. But you can just see, and what if you do get access to this presentation after this, you can listen to the sound of this debris, people walking along. It's a complete you know, destruction. And then the consequences are, it has to be rebuilt, and then insurance coverage for the rebuild and the coverage and the rebuilding to new standards and all the various criteria that the principal has to decide. And then we have, you know, the consequence where we would be coming in as underwriters and insurance people is the insurance policy for the rebuild. I think that's just a snapshot of how serious it can get. And I'd like to hand over to the next presenter. I think it's Mamoon. Thank you everybody for listening.
Thank you, Richard. Good morning, good afternoon, everyone. Thank you very much for reaching this point. Now, we are going to be talking a little bit technical about the cladding system and the cladding types. When we talk about cladding, we really need to be a little bit careful about a couple of things. Cladding in general is not really a bad word. It's not really a serious issue in general. It is certain types of cladding that we need to be careful about and that we need to worry about. So cladding systems in general, there are quite a bit of them. Some of them are non-combustible, have no problems whatsoever, and we don't really need to worry about them. The only ones that we really need to worry about are certain types of cladding that have combustible material as part of the core of the cladding. So on the next slide, we come to really define what the problem is and where we need to worry. We need to worry about a certain type of cladding with a core that is made of a material that is combustible. Now, not all of it has to be aluminium composite panels. They don't always have to be aluminium. In general, when we talk about cladding of concern, let's call it, then we're talking about a composite panel, or what is referred to sometimes as a sandwich panel. Basically, we have two thin layers of metal, and right in between that metal, we have a core material that is used to actually provide some sort of strength and protection against wind, loading in the material. So it is a material, or it is a component, let's call it a construction component, that is very, very important for the construction, and it provides quite a bit of protection to the building. So if we look at the next slide, we look a little bit deeper about the core issue, or the core inside the sandwich panel. On the next slide, Andy, if you please, we will see that in a composite panel structure, we have a low density core inserted in between two relatively thin skin layers. We use some sort of an adhesive to hold them together and create that setup which allows excellent mechanical performance at minimal weight. The high rigidity of the sandwich panel is achieved because of the interaction of the components under load applied to the panel. The problem, or what we really need to worry about, as the next slide shows us, is the core material. What is the core material that is used? Before we get to that, let's go into the different types, and the next slide, where we talk about where do we expect to find these composite panels. Some of them, and the majority, a lot of them actually, are found outside on the external cladding on buildings. There are different types of cladding and different types of material, but they are very, very common on the outside. The next slide, though, is very important because it actually shows us that they also exist quite a bit internally. And they exist internally in buildings where you need to achieve some sort of a cleanliness level. So you find it quite a bit in labs, you find it in food processing, you find it in certain types of warehouses or manufacturing, like pharmaceuticals and other places. And you find it also in office space, where you need to have some sort of a protection, or some sort of a good appealing look inside the building. Now let's go and start looking at, try to look at the type of core. There are many different types of cores. We worry about 2 or 3 of those that we have proven, or that tests have shown, are very combustible and have very little fire resistance. Unfortunately, they are the most widespread, or wide used in the industry, because of how cheap they are and how rigid and good quality they can provide to the building. Let's look at those one by one. Let's start first of all with the polystyrene. The polystyrene should always be treated as combustible. And I'm going to try in here in these slides, as I describe these cores, I'm going to try to mention some testing standards that we need to be aware of. These testing standards and the results of these testing standards, we took those out from the presentation, but they are going to be in the paper, which talk about what is the testing standard and how does it apply. And that's really important to keep in mind, because there's quite a bit of different testing standards and different classifications and different description of this material. EPS is by far the worst because it has absolutely no fire resistance. So it feels very, very similar to your packaging material. If you order something and it arrives, it will have that polystyrene inside it. Unfortunately, it is very common and it is used quite a bit. After that, we talk about the polyurethane. Polyurethane, in some instances in the next slide, the polyurethane actually is a little bit more dense and a little bit thicker or a little bit heavier. Because of its density, because of the type of material, it does actually provide some fire resistance, but nothing to speak of, nothing really serious to actually acknowledge or think of it as fire resistant or fire retardant. Now, it is sold as panels with enhanced fire resistance. That's a term that is used by some manufacturers. It doesn't really mean anything in terms of testing results, in terms of fire resistance, and in terms of the ability to resist fires and to provide any protection. Remember, we talked about there are testing standards that have to be met, and testing standards that decide if the material is good and applies, is combustible or non-combustible. Unfortunately, as these panels are sold, and we have run across this situation in many places and in many countries, as these panels are sold, in many instances they are sold and presented as either fire retardant, fire resistant. Nobody says it's non-combustible, but they add these little terms on them and they don't mean much. What we need to go back to really are the standards. In this case, the LPS 1181, some people will say, which is the standard for testing this material, some people will say it is compliant. Some manufacturers or suppliers or distributors might say it is compliant. Yes, it meets all the standards. It's always important to request a certificate showing that it actually is compliant and should be or can actually use. If we look at these two types and the burning characteristics in the next slide for the EPS and the PUR, you're going to notice that these are very, very when these panels are exposed to fire, what happens is the adhesion that is holding the thin skin panels and holding it around the core starts breaking off and getting consumed and starts failing. When the panels or the metal starts opening up, the core catches fire and it spreads very, very aggressively. In most cases, these two types, the EPS or the PUR, the buildings become involved in the fire very quickly, and you can actually bet that it will be a total loss, especially if you find them on the walls, especially if you find them on the outside and as well as the inside, especially if you also find them in the roof panels. So when you find them in all these different locations, once they catch the fire, just like Richard have demonstrated in the case in Haramain, you will notice that it will spread very rapidly, it will spread very aggressively. It is very difficult for the fire services to actually control it. Now we come in the next slide to the PIR. The PIR is better. It's a form of polyurethane with significantly increased levels of fire retardant. Most PIR panels, and just underline the word most, not all, most PIR panels will actually be LPS 1181 approved and or FM 4880 approved. Now, again, in terms of construction, if it is a construction project, then we need to actually request and see evidence, because it's not all approved. The majority of them, or many of them, are approved. If you look at it, it's a little bit yellowish. It has a pale yellow compared to the PUR, which is a little bit denser and shows a little bit darker yellow. The burning characteristics for the PIR in the next slide, actually it will tell you quite a bit of what you need to know about it. It has a much better fire performance than the EPS or the PUR. Because of time, again, because of time constraints, we have to take this testing information out. But fire performance, when we say fire performance, it relates to several characteristics. One is how long before it catches fire. When it catches fire, how quick does it spread? And one is very, very important, which we have observed, or in most cladding fires, is the fact that how much is it going to spread the fire? Does it form burning droplets that will actually spread the fire beyond the building to adjacent buildings and other locations? Like Richard showed, the ticketing area inside the Haramain station, all of that was from falling debris or falling burning material, which will catch additional fires and will cause damage to other parts. So the burning characteristics are always studied in terms of these characteristics, or in terms of these testing results, and you can actually decide if the material is good enough or has good burning characteristics or not. Now, of course, the next slide, we bring in the material. Not all material is a problem. We have material that is really, really good, modified phenolic, MPhen. This is material that actually approved. Most of it or all of it is approved, and it's treated as an effective non-combustible core. Guess what? It's very expensive as well. So not a lot of contractors or a lot of suppliers or a lot of projects would actually have it put in. So that's where you really need to find out what is the type of the material and whether it is something that has been passed, or does it comply with the standard. Another kind, which most of us are aware of it in the next slide, is the mineral wool. Mineral wool is it is a type of insulation made of wool and glass wool, and it is non-combustible. So it's very, very good, excellent insulation. It's heavier, and at the same time, it is also very expensive. That's why you don't find it as common. Now, if you look at the burning characteristics, the summary of the burning characteristics on the next slide, you will see the test results. Actually, you probably will not be able to see this because of how small it is, but it is going to be in the paper. And it is a published table that actually tells you, or compares these different types, compares the cost, the fire resistance in terms of minutes, how long before it actually ignites and breaks away or disappears. It will catch fire, but what happens to it? How long is it going to provide you some sort of resistance? And the probability of a fire spread based on whether it actually is going to, the fire is going to grow within the core panel or within the panels themselves, as well as whether it's going to actually start dropping off certain burning droplets or burning parts, which will start actually growing or catch fires in different locations. So what do we do as risk engineers? How do we tell? I mean, if it's under construction, it's very easy. We just ask them for the certificates. We look at it. We decide what is going on. We go to the warehouse. We look at the type of panels that are under, and we see it. But we are dealing sometimes with situations where we can't actually do it because it's an existing building. It's very, very difficult when you look at a building to decide what is the type of the core. I had that problem, and I always will go around looking for somebody who forgot to fill in an opening to just kind of try to peek in and see what type of material is being used. I typically look at the openings in the wall for fans in warehouses or for windows or something like that, where you can actually look inside and decide what is the material. And that is what is the difficulty, because in most cases, when I ask somebody and say, can you tell me, show me the certificate for the panels or whatever, even in recently built warehouses and buildings, like as recent as 5 years or less even, nobody has the information. Nobody knows what is actually going on, and nobody has anything that they can actually share. So to assess the risk, and this is very, very important, we need to actually determine what is the type. We need to establish it one way or another. We need to try to find it. If we don't find it, we need to go and start asking questions. And in many cases, especially recently, in many cases, you will find a lot of that information available in many locations. I just want to remind everybody that the fire problem is not a cladding problem. The fire problem is a much bigger problem. Cladding is only part of it. And compartmentation, fire protection, occupancy, all of these things are part of the fire problem. And it has to be considered that way. We can't actually focus. We have to consider the cladding, but we can't just say, oh yeah, it has mineral wool cladding, therefore this building is safe. So there is a lot of these things that have to be considered. How the cladding is installed, what does it do, and how does it do it is very, very important. Now, a lot of people and a lot of underwriters will ask for whether it means the building regulation or not. That is very, very important. Like we have discovered through investigating some serious fires in different parts or in different countries, not all regulations have been updated. Regardless of all the high profile cases that have taken place and everybody knows about the problem and so on, not all countries have actually updated their building regulations. Building regulations in many countries remain behind on that situation. It's unfortunate, but that is a case, or that is really the fact of the matter. In addition to that, we have also other problems related to manufacturers using terminology that doesn't really represent the facts. So there are a lot of things that have to be considered. I would suggest that you reference the testing parts and the testing standards in the paper that we have captioned, because there are so many of them as well. It's not just a British standard, it's not just a European or a Euroclass or an international standard. There are so many of them, and they all test different things, they all report in different ways. So you really have to have a little bit of understanding of how these things apply and how they all work together. With that, I turn it over to Tim. Thank you very much for listening.
Thank you, Mahmood. Right, if we go to the next slide, Andy. So I'd like to talk about the key risk factors. So obviously the composition and combustibility of the core material is key. We've talked about the aluminium composite cladding, which is responsible for about a third of the flames. So the amount of this is obviously key, and the extent of this in the building, particularly in vertical sections, but also in the case of Haramain station, it proves that the horizontal spread is important as well. And within the ACP, we need to know what type of substrate is being used. If we're concerned about fire within the ACP, then we need to consider where the sources of ignition are, so potentially balconies and other sources, and the proximity of it to that as well. And within that, the building height and the occupancy are key. What are the fire protection measures installed, particularly for completed buildings? But of course, we're looking more at the CAR side of the risk, so we'll need to know what the temporary fire protection measures and detection is as well. What level of fire resistance has been defined in the code, and the distance from nearby buildings. You can see when these structures catch fire, there's very intense heat that can last So in the case of Haramain station for maybe 2 days. So you need to know how close other buildings are, considering the potential for fire spread. What are the emergency warning systems installed? And also, is the building designed on alternative solution provision of the building code by a fire safety engineer? Thanks, Andy. So underwriting considerations. So design. So when you're designing cladding for wind loading, it's important to know that design codes are normally designed to take into account buildings of maybe 5 or 6 stories high. If you're looking at a high-rise building of 30 stories, then it will have been wind tested. So if you're looking at cladding stability and issues of waterproofing, then you need to have a good view as to who's done the wind testing and are they reputable. Now with a high-rise building, with cladding, there's going to be repeat design. So it could be one panel, one fixing that's repeated throughout the structure. So you should consider repeat losses, or is a series loss clause applicable here? And consider issues that relating to the cladding panels if they're not fire resistant, or if they're below fire resistant. If you have that, then there's a greater likelihood of the cladding catching fire in the first place, but also through spreading throughout the building. And if you look at your MPL scenarios, if your building comprises of several buildings, there's a higher potential for fire spread between the buildings because of more intense heat, and the likelihood of the cladding on adjacent buildings will be more susceptible to catching fire. So that could alter your fire MPL scenario. And with a fire inside a panel, it might take longer for the site team to be aware of the fire. And once they are aware of it, it can be very difficult to put it out because it's within the aluminium cladding. And when we look at the manufacturer, do we know the name of the manufacturer? Is there a reputable supply chain here? Is the cladding of standard, is it a bespoke, or is it standard cladding, and what's the replacement time for this? It's particularly important if you've got DSU there. Site storage. So when the cladding is delivered to site, will it be stored on site, or will it be moved straight into the building where it's perhaps better protected from water damage? If it's stored on site outside the building, then you have the exposure that it could be exposed to the weather, or it could be exposed to plant and equipment hitting it as well. And if it is combustible, then perhaps it should be stored away from the building. And this is more than just cladding panels. If you've got some timber cladding, which we do on some buildings, there's some decorative cladding, then it's perhaps better if that's stored away from the building, such that if it does catch fire, it doesn't cause fire to happen to the building. And then we look at the installation of the panels. How are these installed? So there's 2 main ways. Sometimes generally they're installed from within the building. Now, when they're installed from within the building, there's specialist equipment that lifts them up, pushes them outside the building, tilts them up, and then they're bolted on. But for that to operate, there's no raised floors in the building and no false ceilings, so it's an empty floor plate. If you have to replace a panel once the building's complete or nearly complete, then that method won't work, so you probably have to use a crane from the outside. So consider the difficulty of replacing panels when the cranes are being removed. So consider other construction works. What's the risk of damage to the cladding from other construction works? We have one example where there's been some grinding works on the outside of the building once the glass panels have been installed, and hundreds of these panels were chipped. And there's discussions about whether they should be replaced or not. So again, consider perhaps a series loss clause should be imposed. Maintenance. So if you're providing guaranteed maintenance in leg 3, you're actually giving quite a lot of cover post-construction of the building. So again, consider how practical it is to replace panels once the building is complete. With respect to third party, are the third parties adequately protected from the installation works? For instance, it's not unknown, and it's happened in London, for panels to fall out of a building during construction. So is there a decent separation between the building facade and the third party in the walkway? And consider the effects on the completed building on surrounding property. There's also been examples of London of a south-facing wall focusing the sun on adjacent property. So there's other considerations there. Thanks, Andy. So what this shows is that the exposure is not just to property and CAR insurers, it affects many other laws. So if we go to the next slide. So inherent defects. So if we had defects in the cladding, inherent defects cover will cover you for 10 years after construction of the building. Depending on the maintenance and CAR cover, there will be some overlap. If you have maintenance of 2 years, there's an overlap with the IDI. But within IDI insurance, a likely scenario is cladding replacement, or certainly water leakage and repair of that. You've got liability exposure, so third party exposure seems obvious, panels dropping, etc. But it's very real, and professional indemnity cover as well could be also affected if there's defects in the design. Thanks, Andy. So in summary then, there are many different types of cladding. We've seen you can go from the, what seems to be the most exposed to fire, polystyrene, right through to mineral wool and MFM, which are much more resistant. The design factors, material selection, installation and quality has a huge impact on the potential for loss. It has a potential on the likelihood of a fire occurring, and when that does occur, the extent of damage that can result from that as well. Local building codes vary significantly, and built to code does not necessarily guarantee of it being fire resistant. Building procurement needs to encompass firstly life safety, but also long-term resilience. And building owners need to consider ongoing risk management requirements. So this is to continue right through into the operational phase of the building. So I think that's the end of the presentation. So we'll now open up to questions.
Thanks, Tim. Thanks, everyone. Stephanie, have we got any questions in the chat that I can't see? And if anybody has got.
Okay, one has just come up only now, a second ago, which I'll send on to you, Andy.
And can all the panelists turn their cameras on, ready for the questions? Thank you.
Do you see that one, Andy?
Not yet.
Go into questions and open up the question box.
So I think this one is for Haramain. So the question is, can you give us a summary of what the tests and thresholds are for LPS 1181 and FM 4880 approval? So I'll hand that over to you, Haramain, if that's okay. And you need to unmute yourself. Sorry, Haramain.
Actually, I would have to actually go and pull those references, but it is not just one test. It is the LPS 8 or 1881. There is part 1, there is part 2, there is the LPS part the 11, I think, or 1882. There is the British standard, as there is the Euroclass. So I can pull that out if we can push this question later and just give you a quick idea in a little bit, because I really do have to pull that out from a different document.
Yeah, and I mean, I know also that there are different British standard
yes,
as well, because you have the 476, but then you have the full cladding fire standard, where they set fire to the whole system in a rig, which is probably the highest testing standard available. But
right.
and there's an NFPA equivalent of that as well.
Yes.
So they do get. We could summarize those as a response to the question and add that into the paper as well. If when we review it, we don't see that we've covered it in enough detail.
Yeah, so I basically, like I said, it actually looks at the time, the fire resistance, the timing, And then it also looks at the insulation fire resistance, the integrity, how long or how much is the cladding going to hold the integrity, and it divides these different types into grades. So you have internal 1, internal 2, internal 3. This is regarding the part 2 test for the 1181. And really, it moves from one to the next based on how long does it withstand a fire before it loses integrity. So if you are dealing with internal 2, it will withstand 30 minutes of fire integrity, and 30 minutes the insulation has a 30-minute resistance. Internal 1, grade 1, will be 60 minutes for fire integrity and 60 minutes for the other one. Like I said, there's another test, the 1208, the LPS 1208, which actually looks at the, again, the exteriors or exterior panels and classifies them based on the integrity 30 minutes or 60 minutes, and the insulation, whether it's 15, 30, or 60. There's a British standard that also look at these things. The one that is mostly commonly used is the Euroclassification. And the Euroclassification is really very important. It just looks at the contribution to the fire, whether it's non-combustible, limited combustibility, no flashover, or there is flashover in 10, 20, 2 minutes, 10 minutes, 2 minutes, and so on. And there is a classification, Euroclass rating of F, which is brief performance undetermined. We'll definitely include all of these into the paper, or summarize all of these into the paper to be just to make everybody aware of them. I would really think that everybody should be able to access them. Most of these documents are free of charge, and reference them when you're comparing different classifications by manufacturers.
And Haramain, perhaps you could just comment on a lot of the tests are actually against the face of the panel rather than the exposed core, and that is probably something that construction underwriters particularly need to be aware of. Is but it doesn't necessarily mean that the core has been tested for fire resistivity when exposed.
Yeah, in majority of these tests, they actually test both of them. But the fire, they put it within a fire room or a fire chamber, if you will, and then they expose it to a fire, expose it to flames and heat. Then there are two classifications. The integrity actually talks about the entire panel. Is it holding into place? But then there is also a rating based on the insulation on the core itself. Is the core going to hold after the panel breaks down? How long is the insulation going to be standing into place, and how long is the insulation going to withstand it? So it's a combination of the two. And I have to actually mention that DRE has done quite a bit of testing, and some of that testing is done for the Grenfell Tower and has been adopted by the Grenfell Tower, you want to call it the committee or the investigation body. So there's quite a bit of testing done. The most important classification that manufacturers, or that you can ask the manufacturer about, is really the LPS 1181 for internal and 1201 for external, and the Euroclassification. Euroclassification is very popular, or becoming more and more popular right now.
Okay, thank you. Stephanie, do we have any more questions in the chat?
Yes, we do. There's quite a few questions popping up. So the next one is from Santiago Rodriguez. Can you see that?
Okay, yeah. So the question is, are EPS and PUR considered as faulty material, meaning considered covered under Leg 3 IDI guarantee maintenance? Does anybody want to discuss that one? I can probably talk about ACM in the UK following the Grenfell. What we, rather than it being I can't comment really on whether it's considered faulty material, but under IDI covers in the UK, there is a head of cover for failure to meet building regulations. And obviously, following the Grenfell inquiry, there have been a huge number of residential buildings that have been examined and that have been found to have the ACM type cladding similar to Grenfell, or cladding that was incorrectly installed, and they have in some cases triggered that head of cover under an IDI policy. And I know that it's been reported that the largest carrier of IDI in the UK has accepted 7 claims or so, because it isn't a very commonly purchased covering in the UK. But certainly it is not necessarily the core, but maybe the combination of the whole panel method of installation, lack of cavity barriers or fire stopping when the system has been designed and installed. And that is what has led to the proposed overhaul of the building regulations in the UK and the building safety bill that's in front of Parliament at the minute. I don't know if anybody else wants to comment on whether you could consider it a defect for leg 3 or guaranteed maintenance. I haven't come across that, to be fair. No, okay. In that case, have we got another question, Stephanie?
Yes, from Ruben Torres.
Okay, I'll just wait for that to come through.
Oh, it should be there already. It's for Mamoon. Can you see?
Mamoon, can you see that question?
Yeah, I will assign it to Mamoon.
Mamoon, you're on mute.
Sorry, are you sending it through the channel or the questions? The questions section.
If you look at the questions and expand the question box.
Yes. Is that PIR FM approved is being an unusually accepted type of cladding, but I personally do not believe very comfortable as it required a very accurate or acute installation by contractors. This installation is not always fully supervised. So I read it, it's more of a comment, actually, a very interesting comment. The personal experience is that PIR FM approved is being an unusually accepted type of cladding, but he personally believes that he does not feel comfortable, very comfortable, as it required a very acute or accurate installation by contractors. This installation is not always fully supervised, and at the end, we have a false feeling of safety. What is your opinion? I totally agree. If you remember when we had the slide on the fire problem, I tried to emphasize that the cladding and the type of the core is only part of the problem. It's not really the entire problem. And the installation process has to be something that is considered and taken into account. Now, defective installation is something that you probably, after it's all finished and done, you can't really go back and take it apart and start examining it. You have to trust that during the installation, the supervising the consultants as well as the authorities have done a good inspection. But you know, we all learned from the Grenfell Tower that there were some installation problems, there were some installation questions into place and irregularities into place, and nobody knew about them. And I have investigated fires where we go back to the inspector in the city or the municipality or so on, and he says, well, I'm not expected to inspect everything. I'm not really expected to know exactly what happens. I trust the contractor, and therefore I sign off on it. So yes, that is a problem. The installation is something that has to be looked at, and you would have to kind of reach a point where you say look at the entire picture, the overall picture, not just the core and the type of material, but whether it has been installed by a reputable contractor and has it been installed properly. I agree.
Yeah, I think if anybody wants to understand the reality of how some of those issues around on-site inspections, who's responsible for assuring quality, can go wrong, rather than comment on it, I'd recommend listening to the BBC's Grenfell Inquiry podcast, which is released on a regular basis and gives you that sort of first-hand account from the consultants, fire engineering company, main contractor, cladding contractor, building control. It's a very, very eye-opening podcast when you listen to those accounts of how that project progressed at Grenfell.
We have another question.
Okay,
do you see it?
This should be our last one, as I know everybody probably requires a comfort break before they move on to the opening session or the second session of today's leg conference, and I know Tim has to prepare for that as well.
There's quite a few questions, so perhaps we can write back to people after this or at a later stage. The next one was from Rob Aston. Can you see that? Shall I read it out?
Yeah, I can't see it.
Okay.
Stephanie.
What feeling does the panel have in terms of movement on materials type usage arising out of Grenfell and others? Are they moving towards materials with greater fire resistance, or are they waiting to be forced by government?
Andy, I can probably just answer from the...
Yeah.
I think if you talk about the Gulf region, it seems like they're going in stages. You know, you've got the UAE's had a series of high-profile fires, and now the civil defence has become much more stringent on new buildings and cladding, and that's moving throughout the region. I mentioned Haramain as well, that Saudi Arabia now is going to be implementing much more stringent civil defence on these type cladding and finishes. And I believe then the other adjacent countries will, but it only seems to be, I think my comment is, it only seems to be triggered when something has gone wrong. And I think we all want for a proactive approach to actually, to move forward so we don't have these inherent issues. And I think from ultimately principals and building owners in the future are going to have to take big decisions on some of their existing properties, because I think the level of insurance capacity for their exposure is dwindling as well. You know, so there's a lot of things going on. So it's a very difficult question to put an exact summary on, but I would say we want it to be probably, it's happening, but it's probably not fast enough. And also there's existing projects there that have probably been going for a long time that are probably at the final phase where perhaps the owner should be now thinking about replacing the cladding before even going into an operational phase as well. So really challenging decisions, and obviously costly as well.
And that's, I totally agree, and I think it's the second part of the question. They actually, this is what I'm observing, is they have to be forced. In most cases, they have to be forced by the regulations. It's not moving as fast as you would hope, that people are just doing it on their own. But if the regulations is mandating it, everybody is doing it, and that's what I have observed. So.
Yeah, just to add one more point, Moon, as well. I think I'm seeing as well when we meet some insureds, when we go to their projects, that they're not going to take the risk of proceeding with approval of their proposed cladding or finishings, given the fluid nature of the design. So they may sometimes now up-speccing it now to mitigate such delays and disruptions. So some people are being proactive, but there's some still going on, this will just meet the guidelines and that's what I'll do now.
Okay, Stephanie, I think we'll leave the questions there. Thank you to all the presenters and the panel, and to the whole group who contributed to the paper. As I say, it will be published by the end of October. I would just like to maybe hand back to Cedric just to close out the session, if that's okay. Cedric, if you're available.
Yeah, that's great. Thanks so much for the great presentation, guys. I think it really pulls into sharp focus the frequency and severity of these massive claims, and these are only the fire ones to add to all the other lists that have happened previously. It's a big scale problem, this fire on cladding. And I think what's going to help us as a community is that technical knowledge when we're underwriting, to be able to identify the good risk and hopefully work with industry to point them in the right direction of risk mitigation as well. So I think sessions like this, where you're sharing your technical knowledge, sharing your lessons learned, are really good. And on behalf of LEG and IMIA, thank you very much for the presentation. Also, thank you very much to everyone who's attended as well. Guido, as sponsor, do you have a final word?
Thank you, Cedric, and first of all, many thanks to the entire team working on the paper as such. I think it's an excellent team effort on one hand. Thank you also to the presenters for putting together this interesting topic. I think, as we can see from the number of questions that came in, we could have easily added another half an hour, an hour discussing some of these topics, and I'm pretty sure we will have plenty of experiences in the market to keep that topic quite alive. I know in terms of time, I think we should move on. Just formally posing the question to Andy, are you okay to put the presentation onto the IMIA website as is common?
Yes, Guido, thank you.
Thank you, Andy. So we'll have that posted on the IMIA website. I guess maybe like website as well. I don't know whether you do presentations there as well. And thanks everyone. And back to Cedric for final closure and passing on to the next slot.
Okay, thanks very much, everyone. We've got to make it to the next leg session. So enjoy the rest of your days and thanks for attending. All the best.
Thanks. Bye-bye.
Thanks, everyone.